Mm-hmm.
All right, so I guess my screen is visible now, right?
Yes, it is.
All right, so you can see the site. Let me go back.
It is.
All right, so let me just go back. So for you to know what the PV potential of a location is, you go to Google, type Global Solar Atlas. I've given you the site already. I'm just telling you. So you can see it now, Global Solar Atlas. So you type the coordinates, but in this case, I just want to assume it is advisable for you to type the coordinates here. All right, so you can see now Abuja. So when I come to this site now, you can see specific photo. This is what I need, PV out. So that means that the PV capacity that I can get in Abuja, PV out, you can see is 1,508.4. But this is what is for the year, all right? But if I need it per day, so just come, you can see per year. So I need it for the day, so I'll just come here. So you can see what I have per day. What is it? 4.133. All right? Can you see it? So this is the irradiance for Abuja. Now, if you come to Lagos, you notice that there is a difference. Let's see Lagos. What you have in Abuja will definitely be different from, obviously Abuja is not, so it should be, you can see what Lagos zone is giving to us, 3.8. 3.8. That's the reason why I keep telling you that if I'm going to be installing...
Where that 3.8 is.
Sorry?
I'm trying to search. Please, can you show me where that 3.8 is? I'm trying to check it out.
All right. Can you say 3.8? Please mute your mic. 3.8. Can you see it now? Can you see
it? Yes.
All right. So if you go, let's see Kano. Definitely Kano will be higher. All right. So you can see Kano is 4.657. Can you see? So that's the reason why the energy that you'll be getting from Kano will be different from what you are getting in Lagos. All right. So if I'm doing an installation, let's say CNI for a customer or a facility in Kano, I can be charging less, all right, than what I'll be charging in Lagos, just to ensure that my financial book is balanced. Please mute your mic. And then you can mute your mic, just to ensure that it's balanced. So that is it. So now that we already know how to get the PV potential of our location, since we already have 5,000, so you just divide 5,000 divided by the PV potential of the location. In this case, now let's use Kano, we have our 4.657. So when you divide, what will you get? 5,000 divided by 4 points. What will you get? What will you get? Divide 5,000 divided by 4 points. 5,000 divided by 4.56.
1,086.9.
1,086, right?
0.95.
Good. So that is what that's the capacity that I'm going to size with. Do you understand that? So that is the capacity that I'm going to, but obviously you will leave a tolerance again and so on like that. So that is how to size using your login. Now, if it is my log, if it is what I logged, what I need is just the, when you are logging, you get the average energy. You get the daily average energy, right? Now, let me show you a login details. Let me show you this. Let me show you a data from my login, from my analyzer. I'm coming, Solar Pro. I want to show you what I logged. I'm coming so that I will be able, so that you see, you need to, even if you log, like I mentioned to you, your login will not be accurate. I'm coming. Okay, I'm coming so that I can show it to you. Okay, this is it. Can you see my screen? It's still loading. Oh, just calm down.
Sure.
All right. So I've just explained to you how to analyze the electricity bill in case. All right. Now let's see this logged. This is a logged value. Can you see how scattered it is? This is for my logger. This is for my logger that I'm using. So can you see? In fact, a layman will understand this. Am I right? You can understand this, right?
Yeah.
Can you see my screen? When you look at this, this is all right. This is what single phase. That is line 1, line 2, line 3. You can see average low. That's the average current for A, for B, for C. This is the average. UM means what voltage for neutral. You can see is 0. This is line to line voltage. You can see this is the average. You can see current for A, current for B, current for C. This is the average. Current for neutral. You can see this is the frequency. This is the power factor for A, B, and C. All right. This is the total. Can you see that's the total? It's just the average. So you can see the. So in this case now, what I just did is just the power. You can see P1, P2, P3. This is the summation of all the power. So this is what I need. But you can see it's in kilowatt. I need this. Can you see it? So if you are logging, this is the parameter that you need. I need this parameter. Then I also need the energy. What is it? You can see this is reactive power. This is apparent power. This is the energy. You can see the energy. You can see the energy. Energy for 1, energy for 2, energy for 3. You can see this is the summation of the energy. You can see this is what I need. These are the 2 parameters that I need. So if you do your logging cannot give you everything. Your logging cannot give you what you need. All right. So your logging will simply give you will give you a scattered diagram. So once you have the scattered data like this, you just need to streamline it. Let me share you one of the streamline how to analyze data from my system. I'm coming. Let me share with you so that you see how I was able to. That's the rough data that I have, but I was able to filter it. So I want to show you the filter data that I have so that you understand the parameters, the key parameters that you actually need. All right, because it's not all the parameters that you need. It is not all the parameters that you need. Okay, so I'm going to show you now for you to see. All right, so you can see what the energy is. So with this now, I can know what the daily energy is. I can know what the monthly energy, because this is actually conducted for 7 days. It was actually conducted for 7 days. So let me show it to you. Let me show it to you. It's coming up. Okay, so this is it. All right, so it's coming up. So can you see it now? Can you see? I need the dates, the time, and the. Can you see my screen? Can you see my screen, please?
Yes, please. Yes.
Yes, you can see.
What you can see there from this nonsense that you can see here, you can see now it's not all the data that I need. I only need the total power. All right, and I need the energy. That's all that I need. So I was able to filter this. So you can see now that this is when I start. Can you see the time? Can you see the time? It's just for 3 days. So when you look at this, guys, and it is very good for you to always represent using graphs so that you'll be able to understand it. Now, when you look at on this day now, on this day, I should be able to know what my peak load is. I know that my peak load is more than 100. Can you see? On this day, I know that it's close to my peak load is not more than 100. So with this now, you can know what the peak load is at a glance. All right. So now when you come to energy, you can see the energy as well. You can see here now that on this day, the energy consumed is the ending energy is what? Is around 1.3 and the starting energy is around 1.2. So when I subtract, I'll have my energy for that day. I don't know if you understand what I'm saying. The energy here is this 1,400. So if I want to do this now, this is how I'm going to do it. If I want to know the energy, you can see on the 15th. On the 15th, I started logging on the 15th. If I want to know the energy that I consume on the 15th, what I need is just the last energy for that day. I will come to the last. Can you see on the 15th? This is the last day. Can you see this is the energy that I recorded on the last day? Click on it minus the energy on the first day. This is it. This is it. So that means this is the energy that I consume on the 15th. All right. And remember, if the discos are billing you, they don't bill you per kilowatts. They bill you per the energy. So if they're going to bill me now, let me assume I'm on band A. So they will not multiply the band A. They will put, what's it called, tariff. So for band A, including tariff, is 209.5. So they will just multiply 209.5 with this. So then you have this to be the amount that you'll be paying, that you pay for that day. You can see when you do that. So you can see that means I'm paying coming. So that means for this day I'll be paying, you can see 239,000. Can you see it? 239,000. So you can see that is basically how to calculate energy. So that is it from the login. So now let's move on. Let's move on. All right, so that is for the login. Now let's move on. Okay, so if you've gotten the energy per day as well, you follow the same procedure. Just divide it by the PV potential. All right. Now let's move on. Now in analyzing the roof space, because if there is no space that you can put your solar panel, there is no point in proceeding with your design. All right. If the client doesn't have any space on the roof and there is no space on the ground as well, then there is no point, because solar is all about roof. All right. Now in analyzing the roof space, below are the key factors you need to put into consideration. Does the roof have enough space? All right. Is the roof strong enough? Now remember, the one that I want to do now, using the 1,000, that the 150,000, and we've gotten a solar capacity of, let's say, 1 megawatt. That's 1,000 kilowatts, right? Now, since we've identified the capacity, then the next question is, do they have the space to accommodate that capacity? All right. Now, there's a way you can do a rough estimate to know what the area is, and this is it. Then the next one is the roof strong enough? This would be for this, what's it called, the structural engineer to identify this. Now, this is how to know what the area of, how to calculate the area of a roof without you even visiting the site, or without you, concluding. Now, this is a 1 kilowatt solar requires approximately 3 panels. I'm sure you know that. Now, area of a panel, if you check a data sheet of a panel, if you check the data sheet of a panel, you will definitely see that the length is around 2.74 something. Then the width is around 1.3 something. All right, so we are just assuming, here, because when you multiply that area, it can give you 3, it can give you 2, but we are only assuming here. All right. Now, 1 kilowatt, I want to use a base capacity, which is 1 kilowatts. That's the base capacity that we are using. 1 kilowatt solar requires approximately 3 panels. All right. Now, area of panel is 2 square meter, which I've just explained to you. Now, for 3 panels, it will require how many area? That is 6 square meter. Now, considering all the spacings for shadow, etc., the total area required, we approximate. It's meant to be 6 square meter, but if you want to factor in, shadow spacing, let's just say the area is 8 to 10 square meter. All right. So that means here the total area required for a 2 kilometer plant will be what? 16. So this is just it. Let me give you this hint. Just note that. Just note this. Just note this. Hello, can you hear me? Now, rule of thumb. Just note this rule of thumb. That 1 kilowatt. Note this rule of thumb. That 1 kilowatt peak of solar capacity we require what? How many square area? Require 8 to 10 square meter of area. All right. When you know this, just note this rule of thumb. Note this rule of thumb. 1 kilowatt peak of solar capacity will give us 8 to 10 square meter. Meaning that if I want to do 100 kilowatt, if I want to do 100 kilowatt peak, all right, what area do I need? That means just 100 times 8 to give that. I will need up to 100 to what? 1,000 square meter. Do you understand that? I will need up to 100 to 1,000 square meter. Now, what if I want to design let's say 300 kilowatt peak? I want to design 300 kilowatt peak. Now, I need someone to tell me what area will I need. I need someone to tell me what area will I need. What range of area will I need?
2,400.
2,400 to what? 2,400 square meter to what?
3,000.
To 3,000.
So 3,000.
So this
To
is
3,000.
good. So this is what you need. If you don't want to use software, this is just basically, for you to sound professional. All right. Best for you to know without using software. For example, you're having a conversation, you're even in an interview, and they ask you all these questions. You're not using software. You should just be able to be flowing that, okay, 1 kilowatt, according to rule of thumb, 1 kilowatt peak of solar plant should be giving us around 8 to 10 square meters that I need for my solar. So that means that if I'm designing X capacity, I should be requiring. So once you do that, you should sound professional. All right. Now the next step is to check if the client has the available space area. All right. By visiting now, without you visiting the site, there is a way you can know if the client have the area. Now let me go to Google Expo. How many of you have that? How many of you have Google Expo on your laptop? If you don't have it, kindly download the app. Download the software. All right, so can you see my screen now? My Google Pro will not be able to open here. I'm coming because I'm actually using. Okay. Let me see. Please look for Michael. You are interrupting the class, so we are recording. It will affect the recording. All right, so now let's just use map. Let's use map. Let me go to map. Maybe let me use map. I'm unable to open my Google. Let's use map. Let me show you map. Because this system is using a dock station. So that's the reason why. Let's just use map. All right, so let's use map. Now give me any location. I need any location. Who can give me any location that it has a roof? Give me any location that it has a roof. I want to show you how to know the area of the roof.
Lagos.
If I type Lagos, I need a particular infrastructure that is currently running. I need a particular. Okay, let me just do this. Don't worry.
Okay. Fidelity Bank. Faculty of Engineering, Uniben.
Sorry?
Faculty of Engineering, Uniben.
Don't worry. I don't want to go that far. Let's just use this. All right?
Okay.
Now, if you have, this is my map. For those of you that don't know how to use map, this is your map. You can actually remove all these codes, all these words here. So what you need to do is just to go to your layer, then come to more. You remove label. You can see, tick this label to remove. Everything will remove. Then you close it. So I've removed all the labels. So now I want to know what the area of this roof is. Remember, this is the ridge. Can you see the ridge of this roof? So I have this side and I have this side. So I want to install my solar panel on this side and I want to install my solar panel on this side. So I will need to know what the area of this roof is, both of them. So I will start with this side. So what you need to do is just to come to the edge of this roof. Come to the edge of this roof. This is it. Can you see it? You right click. I've right click on this roof. Then you come to measure distance. Come to measure distance. Can you see? Then you take it to this side. Come to this side. Come to this side. Just use it to trace the roof. Can you see? So who can tell me what is the area of this roof? Can you see the total area of this space alone is what? What is the total area of this space? You can see 1,538.56. Can you see it? Hello, can you see how to calculate the area of this roof? Can you see it?
Yes, sir.
Yes.
Can't see your screen.
You can't see my screen. Is it true that you cannot see my screen?
Yeah, we can see the screen.
We can see it. Please come again.
Your photo.
Don't worry.
Please come again, sir.
I won't come again. I will use it. I will use the other side to explain.
Okay.
Now, can you see? This is the distance here. Let me just close it. Okay, let me explain it again. You can see. Can you see the roof?
Yes.
Yes, sir.
All right. So now, once you can see the roof, right? Now I want to measure. This is the ridge. I want to measure the area of this side here. So what you need to come to the edge of the roof. From the edge of the roof, right click. Once you right click, then you see among the items that will populate. Then you see measure distance. Come to this, click on measure distance. Then you now start going to the edges of that point. You can see. Take it to this side. Take it to this side.
Sorry, I can't see your screen. I can't see your screen.
Sorry, is it that all of you cannot see my screen?
No, I guess it's not.
You can see the screen. The side you are working on, that is where you are not seeing. You can see your screen, but the side you are working on, you can't see.
I can see your screen.
I can see your screen.
You can see my screen. Can you see the total? If you can see my screen, what is the total area?
Yes.
The total is 1,532.
So that is so. Why you say you cannot see my screen? I think it's by
We can see it.
All right. So now
It's a network problem. The network is not.
good. So once you already know this area, you write it down. You already know this area. You write it down. 1,532. You've calculated it. Then you go to the other side again. Do the same thing to this side. Come to the edge. Right click on the edge. Come to measure distance. Then you go again to this side and to the edges. Come to the edges. Come to the edges. Then come to this side again. So what do you have for this? What is the area of this?
1,676.15 meters square.
So you add everything together. Once you add everything together, then you have the total area of the roof. Right. So once you have the total area of the roof, then you now compare. All right. If the capacity, you've done the capacity, you know that okay, the area that you need is maybe 5,000. I'm sure you know how to calculate the area, just like I've mentioned here. Just this principle. Maybe the capacity you are installing is 1,000 mega. Okay, now from the examples that we are doing, remember we want to calculate 1 megawatt, right? Hello, from the capacity that we are doing, from the electricity bill. Sorry, if you don't mute your mic, all right, you are affecting the recording, just like I keep saying. All right, so that is just the challenge. Whenever you are going through the recordings, you might be saying you can't hear it because you are not, you unmute yourself, so it's affecting the recording. So if you're not saying anything, please kindly mute your mic. All right, so now from the examples that I gave using the NEPA bill, all right, and we've divided, we are getting 1,000 kilowatt peak. Now let me assume that is the one that I want to do. All right. So now what area is needed for a 1,000 kilowatt peak? What area is needed? Who can tell me what area is needed?
8,000 to 10,000 square meters.
8,000 to 10,000. Thank you. Now coming to these our cross, do you think that when you add both of them together, what are you going to get? When you add both areas together, what will you get? I think
having 3,200 plus square meters. So it's not sufficient for our 1 megawatt.
It's not sufficient, right? You can see it's not sufficient for the capacity. So in this case, what will you do? You simply write the clients that it is not sufficient. There is nothing you can do. All right. So that is how to know the capacity. That's how to calculate the capacity. All right. So now let's move on. Now the roof strength is obtained by knowing the weight of one panel and multiplying with the number of panels to be used. All right. Now, weight of a typical solar panel is 25 kilogram. You can check this in the data sheet of a panel. Now, the weight of a structural panel, we are assuming, remember, if you have the panels on the roof, there will be, you are going to have the aluminum profile, all those ones as well add to the weight. So we are assuming that the weight of the structure per panel is 10 kg. Now the total weight of one panel only will now give us weight of the panel, which is 25, plus the weight of the structure, plus contingency, wind. All right? So let's just assume that the wind is 15. So the total load will now be what? 50 kg. So to know what the total weight that you've calculated by the area of the panel, and remember we say area of the panel is 2 square meters. So when you divide, then the load bearing is what? Is 25 kg. So now, if you have a roof installation and you want to involve a structural design, the terms that you'll be hearing from them is what is your load bearing. All right, what is your load bearing? So this is basically how to calculate the load bearing. All right. So if you want to calculate the load bearing of the total installation, you want to calculate the total of the total installation. How do you go about it? What you need to do is you already know what the weight of your panel is. All right. So let's assume that the weight of the panel is 25. Then the contingencies the structure is 10. Then contingency is 15. So when you add everything, that is 50. So that's for one panel. And if you have, let's assume you have 200 panels. If you have 200 panels, what will be the total weight? That's just 50 times 200. You understand? You're going to get the total weight. Now, to now know the load bearing of the total installation, it will not be 50 times 200 divided by the weight.
10,000.
That's 10,000, you're right. So that is how to calculate. That's the minimum. That's how to calculate load bearing. All right. So now let's proceed. Now we are now moving to the DC coupled system. DC coupled system. All right. Now in a DC coupled system, the DC power from the solar panel can be used directly. Can be used to directly charge any solar batteries with no intermediary conversion to AC. All right. Any electricity needed to power appliances or feed the grid is converted to AC by the inverter as it has any electricity. Now, what this is simply saying is that for your DC coupled system, now basically what you use in residential is DC coupled system. All right, DC coupled system, because what is coming from your solar, the DC energy that is coming from your solar, we pass through your DC, we pass through your charge controller to your battery. So it is from your battery that is being used directly. All right, so that's the essence, that if your battery is not okay, even if you have energy from the solar, your inverter will not work. So that is basically what DC covers. So in a DC coupled system, the DC power from the solar panel can be directed straight to the system battery through a charge controller, can you see, without needing to pass through an inverter. All right. Power from appliances or to feed the main grid is converted to AC through an inverter. But this is the only inverter that is needed. Now, let me just explain this to you. I will use a residential to explain. Now, listen to this. For those of you that do residential, your installation, if you are using a battery inverter for your residential installation, which most of us use, battery inverter in the sense that you have external charge controller. All right. Now, when you have that, the energy that is coming from your panel, all right, will pass through the charge controller to your battery. So your inverter is converting that DC from your battery to your AC directly. All right. So which means that your energy that is coming from your solar panel is not going directly into your inverter. All right. Your inverter is taken directly from the battery. So that is how it is. It is only when you have an hybrid inverter. An hybrid inverter has an input MP, that's charge controller, has a battery, has output, has input. So it is only when you have that you need to set priority that, okay, I want my battery, I want my grid to take priority. So that means anything that is coming from your grid can go directly. But your DC, what is coming from your DC passes through your inverter first. I mean your battery first before it can be taken from your battery. Do you understand that? Do you understand that?
Yes. Yes, sir. We do.
All right. So now let's
But I have a question, sir.
or ask your question quickly.
Okay. In a situation where how are we going to explain this? Where the like what you just explained, the hybrid inverter, where the solar charge controller is inbuilt already. Is it that can we will it prioritize powering the load during some peak hours and then charging at the same time when you size it very well, and will it prioritize or how does it work? So for the other one you just explained, which is the battery inverter, the one with external charge controller, will it also prioritize powering the load as well as charging, or it will first of all charge the battery and then from the battery it will now start servicing the load? I just want to get the difference.
All right. So
Yes,
for this coupled system, it is entering inside the battery first before serving the load. You understand it now? Even if the battery is full, it will just be going like that. Let me just show you an AC coupled. Can you see this is a DC coupled? Can you see this? Can you see my screen?
Yes, sir.
Yes.
So you can see the solar panel number 1. You can see the MPPT charge controller number 2. You can see the battery number. You can see the inverter. So there is no how the energy from the solar panel will bypass the battery and go and serve the load through the inverter. No, it passes through the battery first. So the inverter is taken directly from the battery, not from this guy here. So that's the reason why if your inverter is faulty, like if the inverter is bad, all right, your system is automatic, your system will automatically not work. Do you understand what I'm saying? If your inverter is bad, your battery is bad, even if this guy is working, your system will go off. Like, it's as good as just shutting it down. Go and buy another battery before you start using it. All right. So now to answer your question directly and straightforward, the energy that is coming from the solar panel passes through the battery first before it can be used by the facility through the inverter. All right. It doesn't go through the solar panel directly to the appliances. No, it doesn't. Do you understand that? Does that answer your question now?
Yes, but what about the one? Yes, but what about the one with inbuilt charge controller?
That is hybrid inverter. So now for an hybrid inverter, you need to for an hybrid inverter, you need to let me just show it to you. Okay, now this is an hybrid inverter. Can you see an hybrid inverter? Can you see my screen?
Yes.
This is a typical hybrid inverter. It has an input charge controller, so the panel is entering directly, then it has a battery, then it has input and output. Now in this case, then you can set priority. You know, an hybrid inverter is very smart. An hybrid inverter is very smart. So in this case now, you can set a priority. All right, that when I have during the day, all right, during the day, then I should take my energy from the solar. All right. Then once maybe during the night there is grid availability, then take from the grid. So in this case now for hybrid inverter, since it is a smart device, you can set priority that solar should come. Do you understand that now? Then so time take from the battery. So that's the reason why for an hybrid inverter there is always a dashboard where you'll be seeing the flow. You see that solar is going in. It is because you set priority. So in the case of hybrid inverter, it is different because you can set your priority. You can decide, okay, take from the battery, take from solar, take from grid, and so on like that. Do you understand that? Do you understand that?
Yes, I get you. Yes, sir. But I wanted to be sure because you have detailed it. But what I wanted to be sure is for hybrid inverters, is it when you size your panel to charge your battery and power it, or probably you just size your panel to charge your battery alone? Does it mean that we cannot use our appliance during the day?
Of course, you can use you can use your appliance depending on your sizing. You can size this in such a way that once the battery is full, all these things is not fixed. the load in your apartment is not fixed. It fluctuates. You understand? So once you have a reduced load, the solar panel can charge the battery and be supplying your appliances. You understand? And once the load is more than what your battery, once the solar can charge, then it takes from the battery. You understand? So, like I mentioned, once you install an hybrid inverter, you see the flow on the dashboard. Do you get that?
Okay.
All right. So now let's move on. We've seen DC coupled system. Now let's see AC coupled system. In an AC coupled system, solar panel produce DC, which flows into an inverter and is converted to AC to power appliances. You can see this one converted automatically to an AC. Now, any electricity that is directly to the battery must be converted back to DC by an inverter. Then convert back to AC when battery is discharged. Now, in a nutshell, an AC coupled system have 2 inverters. Now, forget about DC coupled system. If you go to any facility that has battery system, what they are using is an AC coupled system, and that's why you see 2 inverters. One of the inverter is usually called PCS. I'm sure you must have heard PCS before. Have you heard of PCS before? PCS means power converter system.
Conversion. Like Fronius inverter.
Exactly. Fronius is not a PCS. Fronius is not a PCS. Another name for PCS is what?
Like
battery inverter. Are you with me now? So
what is Fronius inverter?
Fronius is a solar inverter. A PCS has, no one you see it. A PCS has, I think I've explained what we did last week. I talked about battery inverter too. A battery inverter, which is another name for PCS, has battery inputs, all right, has an output inverter. Sorry, it has an output and it has an input. There is no charge controller connected to it. Do you understand that? There is no charge controller connected to it. You get that? So that is battery inverter or PCS. So now let me just show you how it looks like. So now let's continue where you will see it again. In an AC coupled system, the DC power coming from the solar panel is converted to an inverter. This is useful for powering appliances or feeding the main grid. All right, but it must be converted back to DC power using inverter in order to charge the battery. You can see. Additionally, electricity from discharging battery must be converted to AC again. All right. This means that the electricity must be converted to 3 times. Now, you can see my screen, right? This is your solar. What I'm simply saying, this is your solar good. This is your solar panel. So the energy that is coming from the solar panel is converted directly to your AC. Remember, what we use at home is AC. So it's converted directly to an AC to be used at home. All right? To be used at home. Now, you can see the battery inverter. The battery inverter can also receive that AC, all right, to charge your battery. Remember, the output of this battery inverter is bidirectional. What I mean by bidirectional is that it can take out power, it can also receive power. That's bidirectional. All right, so it's bidirectional. So once the AC that is coming from your solar inverter passes through this battery inverter, it charges the battery. All right. So when I need the AC power, maybe they're doing the night, I need the power again, then this battery inverter will now convert that DC again to AC. It passes through the battery through the output again. Remember, the output is what is bidirectional. Now, example of a battery inverter is Victron. All right. Example of solar inverter is what is Fronius. Fronius, when you see Huawei 50. Example of PCS. You are right. Luna. You are right. Example of a battery inverter is Luna. When you see Huawei Luna, that's a battery inverter. So now, when you understand this principle, regardless of the capacity, you can design an AC coupled system. Forget about the way you see, because when you go to some installation, you'll be seeing how heavy everything. You see, they will bring a lot of system. Just forget about it. Understand the principle. Now, this is the principle that I want to explain to you now. This is it. Can you see my screen now? Can you see
yes,
this?
Yes, I can see your screen.
Can you see this? All right, good. So now when you look at this now, this is my solar panel. All right? All right? The energy that is coming from this solar panel, first of all, enters where? To your solar inverter. Please mute your mic. When you finish talking, mute your mic, please. All right, so now the energy that is coming from the solar panel comes to your inverter. That's your solar inverter. All right. Now the solar inverter, remember, there is going to be a main bus bar. The reason why you have this main bus bar is because, you know, at times you can have 4 inverters, you can have 5 inverters, you can have 10 inverters. That's the reason why you have a bus bar. And remember, I have taught you how to design a bus bar. All right. So that is the reason why you need a bus bar, because you cannot pass, if you have 5 inverters, for example, now, I mean solar inverter, and I'm sure you know what a solar inverter is. Solar inverter has a DC input and an AC output. So when you have your solar panel, the solar panel, which is DC, will enter inside the DC input of your solar inverter. Then the AC output, which is 3-phase, which can be 2-phase or 3-phase, we enter inside the bus bar. All right. So from the bus bar, you now have a main. All right. Remember your inverter, which is your battery inverter. This is your battery inverter. Your battery inverter also have inputs. All right. Have a battery, then output. This output is a bidirectional. So it is from this output, everything is from even on this bus bar, you will have what is feeding the client. From this output here, you will have what is feeding the client, because from your inverter, from your solar inverter, this is how, I don't want to tell you how the flow is. This is how the flow is, and I want you to listen very carefully. This is how the flow is. Let me just draw it so that you understand it. Let me just save. Let me draw it so that you understand it. But when we get to, what's it called, the design, you understand it. All right, so you can see my screen, right? Now, this is my solar panel. This is my solar panel. PV, all right? Then you have your solar inverter. This is your solar inverter. Solar inverter, all right? Then we have a main bus bar. I'll tell you the reason why we have the bus bar. Then here we have the battery inverter. Then we have this is our battery. Let me see, then we have our battery here. Then we have output of the battery inverter is also coming inside this bus bar. Then input will also charge this battery inverter. Input, this is input. The input can be from either grid or generator, all right? So this is our battery inverter. This is our bus bar. This is our solar inverter, and this is our PV. Now, the energy that is coming from the PV, all right, the flows come here to your solar inverter. Then your solar inverter, remember, what is coming now is already an AC. This is DC, and this is what? An AC. Remember, what we need in our facilities is what is an AC. So once it enters inside this bus bar, automatically I can power the facility. Automatically I can power the facility. Automatically I can power the facility. All right. So now let me assume that the load in this facility is 50 kilowatts. Or let me say the energy that I need from this facility is kilowatt hour. And the energy that is coming from this is 70. What will happen? That is coming from this is 70. What will happen? Out of this 70, 50 kilowatt hour energy will power this facility. Then the remaining energy will pass through. This is the output. Remember, I mentioned that this output is bidirectional. We pass through this output and charge the battery. All right. The remaining 20 kilowatt will charge the battery. So now once the load increases to 7, what will happen? It takes it again from the battery through this same output. Remember, the output is bidirectional. Through this output to power all the loads. Do you understand? So now once it is night time and this our energy from the PV is not working again, then through this output again, which is bidirectional, the battery will be charging it. The input also from our generator or grid can also be charging the battery and be powering, can also be powering the system and be charging the battery. So this is basically how your AC coupled system works. Now, once you understand the flow, you can design any AC coupled system. And I'm sure you know that if you go to most facility now, you will see where they will put capacity. You will see them putting 1 megawatt. You will see, I'm sure you always see a capacity like 1 megawatt stroke 1 megawatt hour. Have you been seeing something like this? Have you been seeing something like this? 1 megawatt,
Yes.
1 megawatt. You've been seeing something like this, right? And what is the gain of this?
Yes.
This 1 megawatt is what is a battery inverter, which is otherwise called what? PCS. Why this is the storage? Do you understand?
Conversion system.
I didn't get you.
Yes, battery. That is a power conversion system.
Conversion system, PCS, otherwise called battery system. So once you have capacity, so forget any capacity. This is the principle. Like I mentioned to you, always understand the principle. Once you understand the principle, you can create your own and you can design any capacity. You can design any capacity. So that is basically how AC coupled system works. Any question with that? Before we move to what's it called? Before we move to factor.
Yes, I want to ask.
We ask your question quickly.
Please, for the generator connection, I think there will be a dry contact.
Which generator is that?
No, the design you did then, I was you are talking about the diesel engine and then other things. Then yes, so there will be eye contact. So the I think I don't know what to draw here.
Is it this one I just
trees,
said?
then yes, so there will be a dry contact.
Yes,
Will there be a dry contact
dry contact in the sense that if the battery
to send signal?
that will notify the dry contact to start charging the battery.
Okay, I understand you now. I understand you. That means when the battery
Alright.
gets to a particular SOC,
Thank you
you
very
send
much.
signal to the generator to come up. Is that what you're saying?
Yes. So based on the percentage, based on the percentage,
Because
and
based on
everything.
the battery SOC, you should say, of course. For example,
State of charge.
Vitron is a PCS. Yeah, Vitron is a PCS. And Vitron has what we call Venus GX. You know Venus GX, right?
Yes, I know Venus.
Venus GX for Vitron. Yeah, that is what sends signal to the battery to the generator to come up. All right, so everything is automatic. You don't need to bother about yourself. Everything is automatic.
All right.
All right, so
Thank
now
you very
let's
much.
see. You're welcome. Factor rule 1 of an AC coupled system. You need to know this as well. I'm sure you know that most small commercial AC coupled system that we have. Please, when you are done asking your question, mute your mic. My tech, please.
Okay.
All right, so now let's see factor rule 1 of an AC coupled system. Vitron inverter. This is particular for Vitron inverter. All right, so the reason why I had to pull this out is simply because that's the reason why you need to study the OEM compatibility before you proceed, all right, with your design. Now, what is made of factor 1? Let's see. In an AC coupled system, a grid-tied PV inverter, another name for grid-tied is what? Solar inverter, is connected to the output of a multi-inverter or quattro, to the output. Remember, you can see this inverter, PV inverter, is connected to the output. Can you see? I mentioned to you that it is the output of this inverter that is connected to the bus bar. And also, this guy is meeting at the bus bar. So both of them are connected together. Do you understand that now? Do you understand that? So it has explained what I've just explained there. in an AC coupled system, the grid-tied PV inverter is connected to the output of a multi-inverter or quattro. Now, PV power is first used to power the load, then to charge the battery. And any excess PV power can be fed back to the grid. Maybe in case you are feeding back to the grid, just like we have here now. When the multi or quattro is actually a branch of virtual inverter, is connected to the grid, this excess PV inverter power will automatically be fed back to the grid. Now, when the multi or quattro is operating in inverter mode, disconnected from its AC input, it will create a local grid or microgrid. Now, the PV inverter will accept this microgrid and will therefore operate even during black outputs. All right, so what this is simply telling us is when you have an AC coupled system, all right, which you have in this diagram. Can you see it now? The output, this is the output. You can see this is the output, this is the input. The input is from the grid. When you have access to this, it can actually feed to the grid. Can you see? Now, when there is more PV power, this is where I want you to take it from. When there is more PV power available than used by the load, the power automatically runs through the inverter in a reverse direction and charge the batteries. Just what I've just explained here now. Can you see? When the facility have 70 and your PV can take, when the facility has 50 and the PV is generating 70, 50 will go to the facility and 20 will charge the battery. All right? Now, if it is necessary to regulate the power that is coming from the PV to prevent overcharging the battery, as well as overloading the inverter, which is this inverter, through a process called frequency shifting. Now, what this is particularly telling us is that, remember, your battery has a particular charging capacity, charging power, all right, which you need to factor. So now, if you don't factor that, now let me assume now that what that is telling us is that, let me assume that my PV is generating 70, all right, and what the facility can take is what is 10 kilowatts. What will happen? The remaining 60 will pass through this my output down to charge the battery. Now, that can actually overload the battery, all right, and because it can overload the battery, your battery inverter will not want that, and since it doesn't want that, it will be shutting down. Don't worry, let's move on so that you understand better. Let's move on. Now frequency shifting is used to regulate the output of power of a grid-tied PV inverter by changing the frequency of the AC. Can you see? Now, the factor rule 1 states that the maximum PV power must be equal or less than the VA rating of inverter charging. Do you understand this? That's basically what the rule 1 is stating. That is for Victron. Take note of that. That is for Victron. Now, what the rule 1 is stating is that, now, when you look at this now, if I have a maximum PV capacity, for example, now, I'm designing, obviously, you know that if you are designing, let me just take this off. Okay, now let me use this. Now, let me assume that, can you see my screen? Let me assume that the PV capacity is 20 kilowatt peak. The PV capacity is 20 kilowatt peak. Right. Now, who can tell me what will be my PV capacity? What will be my PV capacity? I mean my PV inverter capacity. If I'm designing 20 kilowatt peak, what will be my PV capacity? Obviously, your PV capacity should be the same thing with this, right? Huh?
Should be equal to or less than.
Equals to or less than. Am I right? It should be equals to this or less than it. Do you understand me? Now, if your PV capacity is now, your inverter VA should be what? Your battery inverter should be what? Should either be equals to, if my PV capacity is 15, that means this guy too should be 15. You understand? Now, factor 1 is stating is that if my solar capacity, that's my solar inverter, is what, 15 kilowatts, all right, then my battery inverter should be the same capacity. Do you understand that? That is what my PV, my factor 1 is stating. Let's go back to it again. Factor 1 states that the maximum PV power must be equal, all right, or less, can you see, than the VA rating of the inverter. I'm sure you should understand this now. You should understand this now. Now, let's move on. In both grid-connected and off-grid system with PV inverter installed on the output of the inverter or quattro, that there is a maximum of PV power that can be installed. Now, what is he saying now? If I have 3000 VA, you can see 3000 VA, this is a Victron inverter. The capacity, installed capacity should be 3, you can see. It should be 3. So as for if I have 8 VA, the maximum should be VA. Do you understand what I'm saying? Now, if I'm parallel these two, if I should parallel these two together, my capacity should also be 16. Now, let me just hint you this. Let me tell you this. There is one site I was managing some years ago.
Excuse me, sir.
I can hear you.
Please, speaking of the rule 1 thing, I know we're talking about the Victron inverters now.
Yes.
Does this rule applies to other systems?
No.
Or is it different from other systems?
Yes, it's different.
Okay, noted.
So that is the reason why the reason is simply because of the compatibility. You know, we are using Victron and Fronius. You understand? If you are using Victron and SMA, remember Victron is the battery inverter. Victron doesn't have, they don't have solar inverter. Are you with me now? Victron doesn't have a solar inverter. They don't have PV inverter. What they have is battery inverter. I'm sure that once they have solar inverter, that principle will change. But as for now, they don't have solar inverter. So their battery inverter has a compatibility issue with Fronius, Solar Edge, SMA, Huawei. So as far as you are doing that, you need to obey the rule 1, the factor rule 1 rule. Do you understand that? You need to obey it. Else. Now let me tell you what that else is. I will use my installation to explain. There's one installation I was done. I didn't do the installation, but I was asked to manage it. So now I realized that each time I check the site on Victron platform, I realized that my PV is always shutting down. All right. Now, this is the configuration of the site. In the site, we have PV inverter. We have 3 PV inverter. We have 3 PV inverter, which is 20 Fronius. We have 3 Fronius inverter. 3 Fronius inverter. That's 20 kilowatts. 20 kilowatts. 20 kilowatts. What is the total? The total is 60, right? The total is 60, right?
Yes.
Good. Then the battery inverter, which is the I have 3 as well, but the 3 is 15. Yeah, 15. What is the total? 45, right? Good. So this is what we have at the site. 20 for PV, 45. Is this right according to rule 1? Is this okay?
Yes, it is. No, according to rule 1, is okay. It is, because it is either equals to or lesser than.
Let's go back so that you understand. Now, the factor rule 1 states that the maximum PV power must be equal or less than the VA rating. What is the maximum PV from that? Is it not 60?
60.
So, what is the VA rating? Is it not 45?
45. Yes. So
is it okay?
It's not.
It is not. It is not. So this is what we have in the installation. Now, let me now hit you this. During peak sun hour, when the sun is heating, when the energy from the sun is damn too much, this PV will definitely go to zero. Everything will go to zero. Do you understand that? Everything will go to zero. Now, if everything is, the yield will go to zero. So at the end, I'm just using from the battery. Now, do you think the installation is efficient? No, it is not. Because during the day, I'm meant to be using the energy from the solar. It shouldn't shut down. Because once it shut down, I'm not using energy from the sun is free. So during the day, I should be using it, not me getting a zero. All right. So at the end of everything, I'm using from the battery. And once the battery gets to 20% SOC, depending on whatever you said, it calls the battery, calls the generator to come up. And I'm using fuel. And if there is grid availability, I'm using grids, which I'm paying for. So why not just do a correct installation, and at the end, you are enjoying the energy from it. So at the end of everything, you now know what I did. At the end of everything, I now switch off one inverter. I decided not to use one inverter. So since I decided not to use one inverter, I'm not getting 40 from here, and I have what from here? I have 40 from here, and I still have what from here? 45.
45.
Now, is it okay now?
Yes.
Is it okay now? Yes, it's okay. So that is what one is all about. Do you understand that now? Do you understand that now? So that is what it's basically
much better now.
Now, when you look at this now, for an oversized PV array, where the total watt peak PV installed exceed the power of the inverter, you can take the watt from the inverter. For example, we have 7,000 solar inverter with a 6,000 watt PV grid inverter. The figure to be used in the calculation is 6 watts. So just note this principle, then you work accordingly. All right. Now, for an undersized PV array, where the total watt peak of the install is less than the installed PV grid inverter, we use the watt peak from the PV panel for your calculation. Can you see? So when you go through this, then you understand. Now, 1 kilowatt peak installed power requires, this is just normal principle. Now, each additional
yes, sir. Before you go further, sir.
Okay.
Hello, sir.
I'm with you.
Hello, sir.
Yeah,
before you go further, if the capacity of the battery is in the other way, that is higher than the PV inverter, what will happen? Because now,
come again. If
the battery, the capacity of the battery, you said it's 15 VA, and if the capacity of the battery is far higher than the solar inverter, what will happen? Because we know the other way you
you said that it will work, but you wouldn't want to do that. That's waste of that's waste of resources. You wouldn't want to do that.
Okay.
You wouldn't want to do you wouldn't want it to go far, because why would you want to? For example, now your capacity is this, and you now decide to have let's say you have 6 of this. That's 15 times. That's waste of resources now. Because out of everything, what will you be using? You won't optimize it will work, but you won't optimize the nobody can even design that. That's waste of money. You understand? So nobody wants to design that. All right, so now let's move on. So now if you have, this is just it. If you have 1 kilowatt, that's the installed capacity. This is just like a rule of thumb, you have this storage. All right. So if you have this type of capacity, try and require this storage. If you have this type of capacity, then you can increase. So once you understand this, then you know how to size your battery. Now below is the link. This is the link. You can read more of it. You can see for Fronius, this is it. For Solar Edge, this is it. Even for SMA, you can. So it is a big challenge. So that's the reason why you should always ensure you size accordingly. All right. Now let's see steps in designing AC DC coupled system. So this is another steps. Now let's see. Determine, this is the first step. Determine the load profile. All right. Select the inverter, size the PV array, calculate the battery bank, select the battery type, select the solar charge controller. So now let's start. This is a typical residential installation. All right. I'm sure everybody will know this. This is a typical residential installation. All right, like I mentioned to you, I don't do residential, but in case this is a typical residential installation. But you can also have this maybe in an office that wants to go green. All right, in an office that decide that, okay, I'm paying more, I want to reduce my cost, then you can decide to just do something like that. Now, when it comes to DC coupled and AC coupled, the usage also, now the question now is, when should I use DC coupled system? When should I use AC coupled system? Now, if I'm fair, I can use a DC coupled system when I realize that this client only operates during the day. All right, maybe it's just a small office and they operate during the day, and their load is not that much. Maybe just 2 ACs, blah blah blah. I can decide, and they don't want to pay much money. All right, I can decide to do DC coupled system for them. But if they operate at night, and you want to carry them all through, definitely AC coupled is what you should recommend. All right, so now let's look at this. I've done this. We have the appliance. You have the power rating in watts. We have the quantity. We have the power. When you multiply everything, convert it to kilowatts, you divide by 1,000, which is this. Then operational hour. I want to operate this for 0.75 hour. Everything is just to get the energy. Energy is the main thing. So you can see the energy. This is it. Now I've added the total power and I've added the energy, which is this. So now let's move on. The first thing is to size your inverter. That's the first thing. All right, because it is the inverter that sizing your inverter will be able to let you know what the system voltage will be. All right. Now, sizing inverter, the input rating of the inverter should never be lower than the total watt of the appliance. What is the total watt of this appliance? What is the total watt of this appliance? You can see 8.135. So it shouldn't be less than it. Now, the inverter must have the same nominal voltage as your battery. If you refuse that, if they're not the same, for example, now the battery voltage, you check your inverter data sheet, they are telling you that the battery voltage is 48 and you are using 12. Sorry, the inverter will not start. All right? Or probably you are seeing 12 as the nominal voltage of your inverter and you are using 48, you will damage your inverter. So you need to watch out for that. Now, for standalone system, the inverter must be large enough to handle the total amount of watts you will be using at a time. Right? The inverter must be greater than the load wattage by 25%, or then we use a tolerance. All right, so this is it. So since we have the load to be this 8.135, we are increasing it. You can see tolerance just in case they decide, because in an apartment, all this load cannot come up at the same time. I'm sure you know that. All this load cannot come up at the same time. But just in case, that's the reason why, just in case they have to bring in an appliance, that is much higher than what we have here. That is the essence of tolerance. All right. So if you decide to size based on this exact, what if they bring another load, blah, 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 then it will start leading to overloads. And you wouldn't want a situation whereby the client will be calling you that this. So just do a clean sheet job. All right. Now search the data sheet of an inverter capacity with a continuous load of 10.58 kilowatts and one that can match the surge power. All right, one that can match the surge power. Now let's go to Victron. Let's see Google. Let's go to Victron. I want to show you something so that you see Victron Quattro 15. Let me show you the data sheet of this Victron Quattro so that you see what I'm talking about. All right, can you see this? Can you see the data sheet? Let me zoom out. Can you see the data sheet?
Yes, we can see it.
All right, good. Now, where I'm coming to is, what is the capacity? The capacity is, we can see, we have different capacity, 3, 5, 8, 10, and 15. All right, so now let's come to this. You can see, can you see this? Can you see this row? Let's stay at this row. Can you see this row? Can you see the row?
Yes.
And if you can see, you can see what? You can see it is even 15. The capacity of the inverter is 3,000 that's 3 kVA at 25 degrees Celsius, 5 kVA at 25 degrees Celsius, 8 kVA at 25 degrees Celsius, 10 kVA at 25 degrees Celsius, 15 kVA at 25. Now, when you realize, now in terms of what, you just have to multiply with the power factor to get this. Now, when you realize that where you want to put your inverter, all right, the temperature there will be around 40 degrees Celsius. Don't size using this capacity. Can you see? Data sheet is very, very important. Don't size using this capacity. So that means that if I realize that where I want to install I won't put AC there. That means that the temperature should be within range of 35-40. Then I will size based on, that means instead of using 3 kVA, instead of the capacity to be 2.4 kilowatts, then it's going to be this. It's going to be this. It's going to be this. When I realize that the temperature there is going to be very hot, maybe 65 degrees Celsius, then this is what I'm going to size it with. Can you see? Can you see? Do you understand that? This is 65. Then these are the peak load. Peak load means that the maximum power that it can stand. This is the peak load. You can see. This is 6,000 watt, that's 6 kVA. This is 10 kVA. This is 16 kVA. 16 kilowatts and so on like that. So you need to know what their current is with respect to temperature. Else, you just notice that your system is shutting down on overload. And that's the reason why we always advise for you to match up with the capacity that is recommended by the OEM. Ensure you put an AC. All right. So now, if the system has motor, compressor, refrigerator pumps, or all these one have what we call starting currents, we need to make sure that the inverter can withstand their starting current. You realize that when you on your fridge, you realize that it draws more currents when it's just starting. Same thing with your load, compressor, washing machine, pumps. So you need to factor in that. All right. So the surge power of these devices is found on the label on them, and if you don't know, you can assume the surge power to be 3 or 4 times. All right. So now let me assume that on this I have for the washing machine now, I factor in the surge power. I've taken the data sheet and I realize that the surge is, I will need to factor everything when designing my system. All right, so that is basically how to get your inverter. All right, let's move to the next one, sizing solar panel. Sizing panel takes into account the energy of the system, and in some cases you need the power. Now the total energy required, remember the total energy for this is 16.82. You can see 16.82, that is the daily energy. Now the total energy needed for the panels will be, you need to consider tolerance. You understand? So this is the tolerance. This is the tolerance. I'm sure you can still remember how we divided the energy. What is it? How we divided the energy that we got from the what is it called? The NEPA bill. The utility bill that we use.
150,000 divided by
exactly. Divided by the peak sun hour, right? That's the PV potential. PV potential can also be peak sun hour. All right. So but in this case, I have to factor in tolerance. Just in case, so you can see now I'm dividing it by the peak sun hour. So I have this to be my capacity. Can you see? So now, for me to now know the number of panels that we need, you don't need to select any module that you use. It might be 500, it might be 200, it might be 300, any capacity that you feel you want to use. So in this case, I'm selecting GCO 415. So to know the number of panels, I just have to divide total capacity, which is this, divided by the power of the panel. So you can see the power is 5.61 divided by 416. But in this case, remember the power is in this one kilowatt, this one is in watts. All right, there's a mistake here. I should multiply this by 1,000 or divide this by 1,000. So it should either be 5.61 times 1,000 divided by 415 or 5.61 divided by 0.415. Do you understand that? So I'm getting 14.5. When you approximate, you have 14 panels. So if I'm going to do this design, I need 14 panels. All right, so the total power of the panels that I need will now be 14 times what? 415. 14 times 415, which is 5810 watts. Now, to calculate your inverter, your battery, this is the formula.
Sorry, I have a question, sir.
Ask your question.
Sorry, for this design, for the for the panel design, you take note of the total energy that is consumed by the client. Yeah, which is okay, but you didn't take note of the wattage, because that power that is consuming is the capacity, is the power capacity, or what the client will be consuming. What about the battery? Because the battery too has its own consumption of power from the panel. So won't you first of all design the battery first, so that you will now be able to know what exact power that will be needed to charge the battery, as well as power the load? Because you are considering the two factors, not just one factor. We are considering the battery, and we are also considering the panels and the loads that the consumer is consuming. So are we not considering the two of them, or we are only just designing for the battery?
All right, so thank you. So when we get to the battery, you see how it will play out. All right, so like I mentioned, the load that you are using in your house is not static, it's dynamic. You understand? What you are using at home now, in your office now, will not be the same thing that you use in the next day. You understand? And that's the reason why we use energy. You get? So this is just the energy that I have here. If I'm going to do the energy for the next day, it might be different. You understand? So this is just an example, and this is basically for residential. Or okay, let's say an apartment, because for offices, because of the computers and the rest. But this is basically a DC coupled system design, not an AC coupled. Do you understand that? So when we get to the battery, you will see how the designs will play out. So ideally, like I mentioned, for DC coupled system, the energy that is coming from your solar is not supplying your load directly, it's only charging your battery. All right, so that's the reason why when sizing your battery, you are considering the energy as well. You can see, you see AH of battery is total energy. You can see the same energy that we consider sizing our PV is the same energy we are considering as well. Can you see it? Yes. Times the DOA, rather, what's mean of DOA? Days of autonomy. All right, that simply means that the days that I want to operate my system, if it's cloudy, for example, that if I realize that I'm not going to get energy from the sun for 3 days, how much energy do I want to have saved in my battery? That's what days of autonomy is. All right, so it can be 1 day, it can be 2 days, it can be 3 days, it can be 4 days. But remember, the higher the days, the higher the number of battery that you use, and the higher the number of battery, the more cost your project will be. All right, so divided by DOD. DOD is what? Depth of discharge. We've explained this when we did battery. Multiplied by system voltage times efficiency. So the system voltage is what is gotten from your inverter. Remember, that's why we have to get our inverter first. If you are sizing a system of, let me assume, 15 kVA, and the battery, we check that the voltage. That's the reason why our data sheet, you can see our data sheet here. If I'm sizing, let me assume I'm designing 10 kVA and 15 kVA, you can see the battery is there already, 48 volts. So that means my system voltage is what? Is 48 volts. All right, so that's what system voltage is. So when you put in those values, AH, you can see I'm also leaving tolerance, because I left tolerance to calculate my, you can see this is the tolerance that I'm using. What is my DOA? I want to use 1 day autonomy. All right, so my depth of discharge is 0. I'm assuming I'm using lithium battery. Then 48 volts is the depth of discharge. Then the efficiency of the battery is 0.9. So when you do that, you're going to have this 599.39 AH. All right, so hello, sir. I can hear you.
how do we determine the efficiency of the system? Because here I can see, here you get
Efficiency of the battery.
Yes. How can we determine it?
From the battery manufacturer, from the OEM of the battery.
Okay. Thank you.
Get that? All right. So now, since we already have our battery now, we need to know how to arrange our battery in series and in parallel. Remember, the battery that we might be using, all right, might be 12 volts, like in this case now, but the system voltage is 48, and the battery that we are using is maybe 12 volts. All right, so you need to be able to arrange your batteries to match up with that 12 volts. So that's the reason why number of series, we need to know how we want to arrange the series, and that will give us system voltage over the battery voltage. And the system voltage is 48. The battery voltage that we are using is 12. So we have 4. So that means we need to arrange 4 in series to get our 48 volts. All right. Now to now know the parallel, because we already have 599.39 To know the parallel, we now have number of parallel AH required over AH of one battery. The AH required is this, you can see. Then the AH of the battery is what? 200. All right, the one battery that we are using is 12 volts, 200 amps hour. All right, but the system voltage is 48 volts. So you need to see how you can arrange it in series to get that 48 volts. And that's how we have to divide this, to get 4. Then to now get this battery capacity, how do you arrange your battery? You need to divide. So when you do that, you have 2, which is 3. So that means that in this case now, to have my battery, I'm going to have one battery here, all right? One battery here, one battery here, one battery here. That is, how many batteries will I need for the installation there? The number of batteries that I need for my installation is what? Is 12, all right? But out of that 12, I need to arrange 4 in series and 3 in parallel. So to do that, let me just take this off. Let me take this off and bring it up again. Let me take this off and bring it up again. So in this case now, you have 12 battery, you have 1, 2, 3, 4. All right? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this is it. So in series, positive of one battery to positive, negative of the other one. Positive to negative, positive of the negative. So at the end, you have positive here and negative here. Same thing, positive, negative, positive, negative, positive, negative. At the end, you have positive, negative. You have positive, negative, positive, negative, positive, negative. At the end, you have negative, positive. So to now combine it in series, remember this is series, then parallel you combine positive and negative together. You can see all positive will come together, all negative will come together. So at the end, you just have positive and negative. So that's how to combine in series and parallel. All right. Now to now size your charge controller, the power of the panels. What is the power? You can see 598. You can see what is the power of the panel is 5810 watts. You can see. So and the system voltage is 14. So that is what I'll use. So in this case, if I'm going to size my charge controller, let me see. Let me just search for charge controller that I will use. Let me go to same Victron. Victron has a charge controller. Let me go to the Victron charge controller that I will use. Victron charge controller. Let me see this. Let me go to smarts. Okay, let me show smarts. Let me see this. Let me just go to smart this. I'm going to see the. Okay, let's look at this. Let me just. I want to get the data sheet so that we can see it. All right, this is the data sheet. All right, so now you can see this. You can see this. Now, looking at this now, for our installation now, we have 510. We have 510. Let me see. Okay, this is it. We have. I'm sure you know how I got this 510 because this is the power. Remember the flow from the solar panel to the charge controller. All right. So the charge controller should be able to accommodate the total power that is coming from the solar panel, and this is the total power. You can see power of the panel we have 14 panels and 415, which is this. And the voltage to, what is the voltage of the battery? The voltage of the battery is, remember, a charge controller has input and output. The input is where the solar panel will enter, and the output is where it will go and charge the battery. So it's both of them needs to match. All right. So once you identify the power to be this and this will be this. So now let's come to the data sheet. Now, do you think I can use this data sheet? You can see nominal power of the PV. Do you think I can use this data sheet? How many of these data sheet do you think I can? How many of this one do you think I can use? You can see 1. This is the total power, nominal PV power, 1160. So I can actually use 5 of this. Remember, 5 of this. I can actually series 5 of this. But instead of making it look cumbersome, we can just go for start for a charge controller that can take this power, and the voltage is what? 48 volts. All right. Now the connection should be done considering the maximum system voltage and the maximum current. We also need to consider that. Now note, it is important to know that an hybrid inverter has input DC. You can see battery inputs, AC input, and AC output, and it is mostly used in DC coupled system. Now a battery inverter has a battery input, AC input, and AC output. Another name for battery inverter is what? Another name for battery inverter is what? We are now. Are you following at all?
Power conversion.
PCS.
Power conversion system. Yes.
All right. So now, the AC output is bidirectional in functionality, and it is peculiar for an AC coupled system. An on-grid or grid-tied or PV or solar inverter has DC input and AC output. So that is it. All right. So now, steps in designing an AC coupled system. Now it's almost 12 already. Will you want us to stop or continue, or you want us to continue?
Let's take a break, you. Break.
How many hours break do you take?
Let's ask the question. I have question.
All right, ask your question. I think we need to stop today. We need to ask your question and we'll continue tomorrow. Don't worry. Let's end the class tomorrow. All right, so we'll continue tomorrow.
So, my hand is up, sir.
Yes.
All right, so you guys ask your question.
Let me ask my question. So because when I design, I normally take notes of both powering the battery and charging I always take note of charging the battery as well as powering the load. And so I normally have I combine them to size my panels. So that means I start with my battery first before I will size my panels. So now my question is, for a battery for a DC coupled system, are we when the solar charge controller is charging the battery, and then it's now the inverter is not taking from the battery, converting it to AC to power the load? How are we going to have during the downtime, as in during night, is the battery not going to get low? At the end of the day, the customer will be complaining, I didn't use this thing within 2-3 hours, the system went off. So I want to be very clear, I understand, because during the peak sun hours, if the inverter is taking from the battery, is it not reducing the capacity for night use? Because night use is what we should consider before, because during the peak sun hours, the panel I believe the panel is powering the load as well, if it is properly sized. So that's my question, please.
Of course, you are right, but if it depends on the inverter that you are using. It's good for you to size your PV in such a way that it will be charging the battery and be supplying the load. Right, that's the ideal way, but it depends on the inverter. If you are doing a DC coupled system, all right, and you are using a battery inverter where you have external charge controller, it doesn't work that way, because it's not powering your load directly, it's only charging your battery. Do you understand that? But if it is an AC coupled system, when you want a situation whereby your battery, your PV will be charging your battery and be supplying the load, then you can do that as well. Or if you are using an hybrid inverter, you can also do that as well. Do you understand that? So you're right, it's good to, your sizing should be in such a way that it should charge the battery and power the load. For example, now, let me give you an example now. For example, now, if the client's load is, let me assume the client's average load, all right, that's the energy. Remember, we are talking about energy in this case, not power. It is energy. The energy is 10, you understand? You notice that the daytime load, the daytime energy for the client is 10 kilowatts, all right? And the battery, of course, you've checked your battery charging capacity, and you feel, okay, the energy that will require is, let's say 20, all right, let's say 20 kilowatt hour. Let's say 20 kilowatt hour. So in this case now, if you're going to size your PV should be sized in such a way that you should be able to get addition of these during the day. Remember, PV is usually sized in kilowatt peak. All right, it's usually sized in kilowatt peak. But at the end of the day, you should know what the energy will be. All right, and what is the energy? Is just multiplying. For example, now you installed 10 kilowatt peak. All right, to know what the energy is just to multiply with the peak sun hour. All right, if the peak sun hour is 3.95, once you multiply, you get the energy. So this is how you'll be able to determine the energy of your PV to know if it will be able to supply the load of 10 kilowatts and be charging the battery at the same time during the day. All right, so once you can do this, then you can size your PV as a result of that. You understand? So now forget formula. I just have to put the formula, this is introduction. But by the time you are a professional already in the design, you forget formula. You design based on the principle of what you want. All right? Do you understand that now, Ayodele?
Yes, I get now. Yes, I get.
Are you
now.
sure? Or you are still confused?
Yes. No, the only thing now I wanted to be clear now is when it is now used, since it's used from the battery now, so will it still be fully charged so that it will now sustain the client for nights where there's no.
Of course.
Where there's no.
Of course, when you design properly, and remember, see, your design is, when you design is on book, but in reality it might not be like that. You understand? If you notice that, okay, this is what the client load is. What if the load is not? What if the energy is not like that? You understand? So, like I mentioned, when you design, when you've done your audit, you know what this is the client's load, and you know what the charging capacity of the battery is, and you size based on what I've just done, then you are good to go. Like I mentioned, it depends on the inverter that you are doing and the system. If it is DC coupled system and you are using a battery inverter, the battery inverter is taking, the facility is consuming directly from the load, from the battery through the inverter. You understand? So that is how it will continue doing like that until the energy from the solar enters the battery. The inverter will take it to power the load. That is how the flow is. So so that's the reason why if you understand that principle, you will definitely know that, okay, this particular customer that operates at night, maybe it is residential, then you can now install hybrid inverter. That's the reason why you see no people are installing hybrid inverter for residential, not using battery inverter. Do you get that?
Okay. So that means for hybrid inverter, the case now will be that it is not only charging the battery but as well as powering the load.
Yes.
I want to get what you are trying to say now. So for a hybrid inverter, so that means it is powering the load as well as charging the battery. While for the battery inverter, which is an external charge controller, it is only charging the battery while it will not take from the battery and power the load. Okay.
Yes.
All right. That's what I want to be clear. Thank you.
If you can add, I don't know, does anyone has an inverter at home that is using external charge controller? Does anyone has an inverter at home that is using external charge controller? if you do, you will realize that that is how it's being done. That is how the connection is. That is how the flow is. All right. So
Hello, sorry, sir.
yeah, okay, you can go. The lights.
Okay. I have a question, just quick one. When you're talking about the battery connection, now I just want to ask, if you connect batteries in parallel, you understand? Let's say we need 48 volts of battery, and we know that okay, there are 12 volts each battery, and then we connected 4 in parallel. What is the implication? Does it have any implication of, is it for does it help for the longer period of the battery, or what is the implication of that? What is the advantage of connecting it in parallel?
Sorry. I think I like your question. Ask again. I think I like your question. Can you come again?
I'm saying that, for instance, now when we need, let's say we need 24 volts of to power a nominal for 24 volts,
Okay.
and then we want to use 4 batteries,
Okay.
and we are aware that each battery has 12 volts, and then we do parallel connection for the battery to get 24 volts. What is the advantage of doing that?
Advantage of parallel, like you series 2 and parallel.
Yes, and
of course, it's longer backup power, longer capacity, longer backup power.
all right, sir.
Then again, I think your question now leads me to what I want to explain, because I think you are going there. This is what I want. Now it's good if you have, now for example, now if you have what do you know that we have 24 volts 5 kVA, and we have 48 volt 5 kVA. Now
Yes.
if you have 24 volts 5 kVA and you have 48 volt 5 kVA, which one will you prefer?
24 volts 5 kVA.
Why?
Yes, for sure we do have.
Because
Which one
of,
will you prefer?
I would prefer that because of the cost implication of the battery.
Now let me just clear this. It's good for you to go for 48 volts, and I will tell you.
Okay,
48 volts. Now let me just hit you this, and I think I've been explaining that to you, that if you know where you need to use voltage and current, ensure you go for higher voltage. The reason is simply because if you go for higher voltage, you're going to reduce losses. You are also going to reduce number of cables. You reduce the length of cables. So if you think you are reducing costs, all right, you are going to pay it back in terms of losses, in terms of accessories that you buy. So it's good for you to always go for higher voltage so as to reduce losses. All right?
Okay.
So that's that. So any other question? Tito, your hand is up.
Thank you, sir.
Lucky hand is up.
There's a question I want to ask, sir. For that, normally when somebody is doing hybrid, they're using hybrid inverter and the battery, for example, Felicity, for example, now. Why do they use this charge controller when there is already a hybrid?
All right, thank you. I love that question. Now, the reason why they use external charge controller, all right, is this. Now, let me just do it. Let me do it here. Now, if, for example, now you remember the inbuilt charge controller is limited, all right. For example, now you have an hybrid inverter. Can you give me an hybrid? Which hybrid? Okay, Felicity, right? Now let me go. Let's be practical. I will show you this. Felicity hybrid inverter. All right, so let's see this. Let me just go to data sheets. Okay, let's see 10 kVA data sheets. All right, so this is it, IVPM. Okay. All right, so can you see this? Can you see these data sheets?
Yes, sir.
All right, good. Okay, now when you look at this now, this is the power rating, blah, blah, this is the AC. Let's go to where we have our charge. Okay, now can you see maximum input power is what? 6,600. Can you see it? Can you see now? Maximum input. Now, the reason why the reason why we use if I'm designing a solar capacity, please mute your mic. All right. Now, since you've identified that the charge controller has a maximum, that's the inbuilt charge controller has a maximum input power of, the OEM has already told you that this is the maximum that my inbuilt charge controller can take. So you shouldn't exceed it. Meaning that if your PV capacity is 10 kilowatt peak, if your PV capacity is 10 kilowatt peak, that means that this can only, that means that out of this 10 kilowatt peak, 6,000 kilowatt peak can only go inside your Felicity. Then the balance, what will be the balance? The balance will be what? 4,400, right?
Yes.
400 will go to an external charge controller. Do you understand it? So that means that if you still want to, if you don't want, that means that using inbuilt charge controller is limiting your PV capacity. But if you still want to go ahead and complete, you want to go ahead and use all the PV capacity, then you need to bring in an inbuilt charge controller. Remember, remember the charge controller is only going inside your battery. There is no connection between external charge controller and inverter. I'm sure you know that. There is no connection. So what you need to do now is, once you want to use the external charge controller, you now need to confirm the compatibility of the external charge controller and the battery that you are using. Your charge controller, you are not terminating your external charge controller inside this. No, you are not terminating it here. Your external charge controller is only going to your battery, not your inbuilt. It's not going inside here. It's only going inside your battery. And remember, like I mentioned earlier, there is no connection between your battery, your inverter, and charge controller. Your inverter only has connection with your battery. So your external charge controller is only connecting to your battery, and you are good to go. All right? Do you understand that?
Yes, sir. And sorry, apart from this thing you said now, you said, okay, since you said the external charge controller has nothing to do with the inverter, it's only connected to the battery.
Yes.
Yes.
So is the solar panel also going to be connected to the external charge controller?
Yes, the solar panel will be connected to the controller. Remember this. Remember you've done this already. You separated it already. 6,600. Then this capacity is going to your external charge controller. So you've done the separation already.
All right.
Do you understand that? You've done the separation already.
Yes, sir.
All right, Ibrahim, you can go next. Or Lucky, or Adeyinka. Any of you can go next. All right, someone is asking, what is VA rating? VA rating is just like kVA. V is voltage, A is amps. All right, it's just like saying kilovolts. Kilovolt amp, that's kVA. All right, so is voltage, that's the unit of inverter. All right, you can ask your question.
Hello.
All right, you can ask your question now.
Yeah, for me, I have only one question.
All right.
I believe we all understand the peak sunshine hours varies with the location, even within the country. I wanted you to help us, if possible, get it online. Let's say for a particular area, could be Abuja or Kano or any other location, so that we really have it. can be bought online.
So I can't hear you. I think where you are is noisy. I can't hear you. Lucky Ibrahim. Okay. Yeah, Morris, go.
Okay. I'm somewhere where.
Good afternoon, sir.
Yeah, good afternoon, Lucky.
Yes, thank you for this thought-provoking.
I can't hear you again, Lucky. Ibrahim.
Can I come again?
Oh yeah, Morris, you can come now. You can come.
Yeah, we understand Big Sunshine Hours.
Go to Dubai, and he brought in 6 number of battery, 12 volt.
Lucky, can you come again? Can you come again? I can't hear you.
And then he actually wants me to use those batteries.
Can you start from the beginning?
Initially, I wanted using a battery inverter, but with your explanation.
Can you come again? I can't hear you.
Yes, I said I had this client. He traveled out of the country. Yes, okay. I said I had the.
Man, I can't hear you again. Oh, I can't hear you again.
Client number of batteries, 12 volts, 200 Ah, and he wants me to install that in his house. He said he wants to be using it to watch his TV and then power one of his deep freezer. And then initially I wanted using the battery inverter, but with this lecture I've understood that I will need to use a inverter instead of the battery inverter. So that means with how you've opened my eyes now, actually it's 6 batteries, and once all of the batteries to be used, the higher voltage will be better.
Yes. Which inverter are you using?
Application were to use Felicity 24 volts, probably 5 kVA. So I don't know what's your take on that.
Go for 48. Don't use 24. Go for 48 volts.
So what there are 6 number of batteries. So how do I utilize that?
Then you can't do it. Then if it's 6, then it is 24 that you do.
Okay.
If it is 48, you will need multiples of 4.
Yes, I'll need multiples of 4.
So you can't do it unless you tell the client that they should buy 2 more.
Okay.
Or you just make do with the 24 volt. You can see it's 24 volt, but nothing since it's residential.
Yes.
No problem. You can use the 24 volts.
All right.
In case of next time, just go for higher voltage. That's
okay, sir. Okay, sir. All right. Thanks a lot, sir.
Okay. All right, sir. I still have another question, though.
Okay.
Yes, you talked about battery inverter and solar inverter. So the battery inverters are the normal inverters to use, like Felicity, Saco. Although you mentioned Victron and Luna. No. Are they the same class of battery inverter?
Because now let me show you how to know battery inverter. Now this is let me go to Victron. Now okay, let me come to, if you check this now. This is Felicity. Can you see my screen now? If you check the data sheet, it has solar. It has PV. It's talking about PV. You can see. It's talking about PV maximum. If you check the data sheet, now looking at this, I know it's an hybrid. That means that it has inbuilt. You can even see MPPT built-in controller. All right. So if you are checking a data sheet of an inverter, and you are seeing among the data, they are talking about charge controller, maximum open circuit voltage, solar charging current and the rest. Just know that it is an hybrid inverter. Now let me go to Victron so that you will be able to see the difference. Let's go to Victron Quattro to know there is a battery inverter. Now when you look at this, if you check this, there is no way, they are not even talking about solar. Can you see this? This is battery, you can see. Let's come down. All this is voltage, you can see. Voltage. This is still talking about battery, you can see inverter. This is talking about you can see when there is nowhere they are talking about. This is still talking about the charging voltage of the battery. Did you see where they talked about opposite voltage? No, you will not see it. So this is a typical battery inverter. A typical battery inverter. And if you read through, you will see where they mention that it has bi-directional. I'm coming bi-directional. They will also tell you I'm coming bi-directional. If you check through, you will see. If you read through, you will see. If you read through all this, you will see where they mention bi-directional. So that's how to differentiate between battery inverter and hybrid inverter. All right.
Okay. So that means the solar inverter, uncle. The solar inverter, is it also the same thing as hybrid inverter?
It's not. Solar inverter has, okay, I think I've explained that. It's in the slide already. This is its notes. You can see this note here. Can you see it? Hybrid inverter has input DC, battery inputs, AC inputs, AC outputs, and it is mostly used in DC coupled system. Battery inverter doesn't have DC input. It only has battery inputs, AC input, and AC output. That's why we use external charge controller for battery inverter. Now, an on-grid inverter or solar inverter only has DC input and AC outputs. Do you get that now?
Yes, sir.
All right. So, Ibrahim, your hand is up. Victor, your hand is up too.
Okay. Good afternoon. Thank you very much for the wonderful presentation. Just quickly want to ask as regards to hybrid inverter.
Okay.
For a hybrid inverter, how do you tend to manage the battery charging? Supposing you're expecting maybe you have enough of sufficient PV supply, and at the same time is powering your gadget. Your load. So the battery is fully charged. So does that equally have effect on the battery?
All right, thank you. Now, every hybrid inverter is smart. So why do it? That's the reason why you don't just install a battery inverter, an hybrid inverter and leave. There are some configurations that you will need to do. All right? Even battery inverter as well. Just like Victron. You don't install Victron and leave. You don't install Felicity and leave. You will do some settings. All right? So they've already told you that this is the maximum charge that your battery can take. All right, so now when it gets to, and battery has different stages in which they charge. They have the bulk stage, they have the assumption stage, and you have the flow stage. So each of those stages receive different currents. So now, even if the battery is fully charged, all right, even if the battery is fully charged, there is what we call flicker. Have you seen what is this thing? What is this thing called? I forgot it. There's what we call flicker, all right? It will remain in 100%, but it will just be we call it trickle charging. That's what we call trickle charging. Do you understand that? It will maintain small current, while the remaining current can be powering the load. Do you understand that?
Yes, I do.
So that is how it operates. Even if you check their data, if you check their dashboard, for example, Victron, if you check Victron dashboard, you will see the stage, the bulk stage absorption and float. That flow stage, the battery is already full. All right. And remember, even if battery is full and you're not using it, it will go down again. I'm sure you know that. All right. I'm sure you know that.
Yes.
That's the discharge state of a battery to go down. So that's the essence of that float. That's the essence of that trickle. It will keep trickling on it. All right. So that's that. Any other question?
Okay. So sorry. Quickly. Does that simply signify that the battery is charging and discharging?
Sorry, I didn't get you.
So with this explanation now, so does it signify that the battery will be discharging and charging again?
No. It will flicker. Just flicker. It will just be flicking on it, not discharging. Even if it will discharge and recharge again, it will be at a slow pace. It will just maintain that level, like that on that 100 level. Just be flicker, but the current that it will use will not be much again.
Okay, thank you very much.
You're welcome. All right, Lucky, Victor, your hand is up. All right, so since there is no question, let's call it a day. We will converge here again tomorrow by 6 p.m. I don't want to rush it, so let's just take our time. So tomorrow by 6 p.m. we'll converge again. Then we'll finish it up tomorrow. All right. Now, tomorrow is basically the design parts. All right. So I'll just try and go deeper, but it might still be some, but I'm sure you will get a lot tomorrow. All right. So, Oguke, your hand is still up. Do you still have a question? Lucky, do you still have a question? So, since there's no question, let's call it a night. Sorry, a day rather. All right. So now, before then, let me even ask: how has been the? Have you been facing any challenge? I'm not proceeding. I'm done with the class, but I just want to ask: are you facing any challenge? Are you facing any challenge so far? Because officially the class should have ended today, but I just want to know if you are facing any challenge. Maybe you've gone through the slides or the recording and you're having any question. Do you have any question aside the ones that we've done today? All right, Victor, you can ask your question. Yeah, your hand is up. You can ask your question, Victor. Victor, you can ask your question. Or if you can't talk, you can type your question. You can type it. I can see that you are talking, but we can't hear you. You can type your question. You can type your question. Now, and again, Lucky, your hand is also up as well.
Yes, I wanted finding out, is it every hybrid inverter that comes with an MPPT
yes.
charge controller?
Yes, inbuilt. All hybrid inverter comes with it.
Okay, because there was a time, I think in 2021, I did install one, I think GSR, the GSR brand. And they said it was a 10 kVA system, 120 volt inbuilt system voltage. So, and they said it was a hybrid inverter. And then the performance is not as expected. So I don't know what happened there. As comparing it to where I bought the same, it was a 3.5 48 volt, and I installed. They said that one too was hybrid, and I did install an external charge controller, electricity charge controller, and that one was performing well. While the other 10 kVA, it wasn't actually performing well. The good thing was that the client doesn't stay in that place. It's actually his farm. So I don't know if it was really an MPP inbuilt or a PWM or so. Hello, did you get me?
Yeah, I got your question. So that's the reason why it's good for you to always check the data sheet. Some can tell you that it's an hybrid inverter. It has an inbuilt MPPT. So it has an inbuilt charge controller. But when you check the charge controller, you realize that it's PWM, not MPPT. So if it is PWM, I will advise you, do not use it. Just leave it idle like that. Go for external charge controller.
Okay.
Go for external MPPT charge controller.
So the mistake has been done. So do you advise now that it's about 4 years now that system had been installed, even though the client there's no much heavy load on it because it's actually a farm. do you advise we get an external MPPT charge controller now and reinstall it? Or
yeah, you can do that. If the client is willing, if you can pitch it to the client and is willing to bring out money, sure, you can do that.
All right, it's okay, sir. Thank you, sir.
You're welcome. So now, Victor, I got your question. I have a client who wants to change from lead acid to lithium battery. Now, if you are migrating from lead acid to lithium battery, or you want to carry out an installation using lithium battery, please ensure you verify the compatibility. All right. If you want to, which inverter is he using for the lead acid? All right. If it is 5 kVA average power inverter, confirm if it is compatible with the lithium battery you want to use. And how do you do that? For example, if you want to use maybe Pilot Tech battery, you can reach out to OEM of the battery or the supplier of the lithium battery and ask if average power inverter, if 5 kVA average power inverter is compatible with their is compatible with lithium battery. Just ask. So if it is, then you can go ahead. If it is not, I'm sorry, there's nothing you can do about it. It's either you change the inverter or you keep looking for a lithium battery that is compatible. So do you get that? So if you got that, just use the same message to tell me that you got it, so that I will know that you're on the same page. Did you get that, Victor? Okay, thank you. All right, so let's end the class now. It's been a wonderful weekend. So we'll continue tomorrow. But tomorrow will be by 6, not in the morning. All right? So enjoy the rest of your afternoon. All right, bye. All right, someone has the slide. The slide will be available after 24 hours. Both the slide and the recording after 24 hours. And the 24 hours starts after tomorrow. Once we are done with tomorrow class, the 24 hours commence from there. So, bye everyone.
Thank you. Bye-bye.